In the previous video, we calculated the price elasticities for the various items and the sell ID combinations that we had. And we have the elasticities now to find the optimal prices in order to gain the maximum profit, which is what we will explore in this particular video. However, along with the elasticities, we also need the actual models that we had created so that we can calculate the quantities at various price points that we want to explore for each product. So let's go back and modify a generic function that we had created, which is here, and now along with price elasticity, it also returns the model. So we'll just go ahead and run all the cells again so that we have the model. And this is an individual product anyways for which there is no data, so it's all right. This is again an individual data and the same error we were getting last time. So now along with each of these price elasticities, we also have their model. And let's take, for example, let's start exploring with Coke. And the Coke data that we had was for cell ID 2051. And since this particular data does not have information about the buying price of the Coke, we shall assume it to be a little less than the minimum price of the Coke which is there in the data set. So if we look, the minimum price that Coke was sold for was 10.97 and the maximum was 13.27. So let's take 9 to be the buying price of the Coke, which is less than 10, assuming that the seller would want to make some profit on it. So buying price, and we shall calculate profit to be the selling price of the Coke minus the buying price which we have set as 9 and multiplied by quantity. So now let's look at the profit at the various price points. So let's say the start price is 9.5, assuming that the seller would want to make at least 0.5 units of profit for each Coke that is being sold. And let's keep the end price as 20. It is just a random number, something above than the maximum value. We could also keep it as at 15, but I thought 20 is a good price point to see the range. So now we create a test data frame with price and quantity, and we shall vary the price from the start price to the end price in steps of 0.01. There's no currency that goes into smaller steps than that. So we are varying price from 9.5 to 20 in steps of 0.01. And we shall calculate the quantity for the same. Now the Coke model that we will be using for this, if you remember, one of the Coke models gave an error. But we are using 2051, so we shall use the Coke model 2051. To predict what the quantity will be at all the various price points that we want to explore. So our test data looks like this. We have price varying from 9.5 and what the quantity should be according to the model that we have created. And it goes on up to 20 and it shows the various quantities to expect for each price point. Now if we calculate the profit for each, as we had said earlier, the profit is basically the test price minus the buying price multiplied by the quantity. So this gives us the profit at all of these price points, and we can have a look at what test looks like now. So it's a 3-column data frame with price, quantity and profit for each. And while this tabular form is quite tedious to look at, let us create some plots. So this is a very simple plot which is plotting price against quantity, which is the blue line. As expected, as price will increase, quantity will decrease. and the price and profit in the orange line. So we see that as price is increasing, the profit is increasing up to a certain point, post which it starts diminishing. And this, the top of this curve, is the sweet spot that we want to identify so that we can price a product to gain maximum profit. So we want to figure out the index. So we have a nice function in NumPy, np.where, and we can find the particular row which equals to the maximum profit that we had seen. And if we see the so this gives us the index, the row index, which is 552. And when we look at it, it gives us the price, quantity, and the profit to be expected. So you can get maximum profit, which is about 131 units, and the quantity you expect to sell at the price you should put for gaining the maximum profit is 15.02, and the quantity that you can expect to sell is 21.78. So this can also help you do some inventory planning, that okay, next week you're thinking of putting this price and this is the quantity that is expected to sell based on this price, and I need to keep 21 quantities in stock. However, keep in mind this is for a normal day. This is not considering any special days, holidays, weekends, or anything where price does not play too much of a part in selling of the products. So this is an example of how we can find the optimal price point to gain maximum profit using Coke as an example. In the next video, we'll write a generic function that will help.